Hello and hi students. Welcome to all aspiring engineers and my YouTube channel presented by Professor Priya Shimpi. In this video this is the very first video on unit 2, that is the transistors and op-amp. In this video we are going to learn about operation in CB configuration. Right? How a transistor can be used in CB configuration. And yes, we are going to see in active region. Okay, the operation we have to study in active region. So in this video also we are going to we also will come to know about why these currents are, collector current is coming inside, why this base current is also coming inside, and why we are drawing the emitter current always leaving from emitter terminal. For which type of transistor? For NPN type of transistor. Why these current directions are like this only. And why also we are trying to find out a answer for the question that why the emitter current is the summation of collector current and the base current. All these answers we are going to find out in today's explanation. Meanwhile, after watching this video, you can also find out the current directions in PNP transistor. Why? The current in PNP transistor emitter current is coming inside, and why the base current is and the collector current is going outside. Right? You have to follow the same steps as I have did in this video, and you can find out the answers for PNP transistor. Okay, so let's begin with, I have told you that CB configuration we are explaining in active region. I told you that transistor is used as an amplifier, right? So it is as an amplifier, it is going to use in active region. Active region means its base emitter junction must be forward bias and collector base junction is a reversed bias, right? For biasing, for this proper biasing, we require the two batteries, VCC and VEE. This VEE is required to make the junction between base and emitter forward bias, and this VCC is required to make junction between collector and base to be reversed bias. Okay, so now what happens when you connect these batteries, we have to study. And one thing I have to told you that I have mentioned earlier, CB configuration is used as constant current source, right? Rather than using as an amplifier, CB configuration is always used as a constant current source. Mind it well, in the active region only. And why this is a question arises, that answer also you can get from this video. Okay, so we have did the proper biasing. The first junction is forward bias and the second junction is reversed bias by using the two batteries VEE and VCC. Now when these batteries are connected, you know the voltage developed between base and emitter, which is the input voltage VBE, okay, and the output voltage will be developed here, it is your VCB. Okay, so start with this operation. Let us start with the operation. So when I connect the negative terminal of this VEE, see this negative terminal, it is connected to the, this is connected to the N type of a semiconductor in emitter terminal. See, this negative terminal of this VEE is connected to emitter, and emitter is connected to the N type of a semiconductor. You know, right? Negative terminal of the battery, it supplies electrons. See this, the electrons will come from the battery, right? So where they will be moving, the electrons, they will move into the emitter terminal, and from emitter terminal they will go into the N type of a semiconductor, right? So can you see the electrons are moving from the battery and from the emitter terminal, they are coming inside of this N type of a semiconductor. So can I say there is a movement of electrons, and this constitute the emitter current IE. And what will be the direction of a current? The current always flows in the opposite to the flow of electrons. So these electrons are coming from the negative battery. They are coming inside of this N type of a semiconductor from emitter terminal. So I always show the emitter current in opposite direction, that is emitter current is coming outwards, right? From this emitter terminal, the emitter current is moving away from its terminal, right? Coming outside, because the electrons are coming inside, right? Now more idea will be clear. So this negative battery is giving you more and more electrons. These electrons are coming N type of a semiconductor. We know that N type of a semiconductor, it already consists of electrons. So the electrons in N type semiconductor and the electrons coming from the battery, now they will experience a force of repulsion. Because of repulsion, what will happen, right? So they will collide on one another, right? So they will collide on each others. Because of collision, they gains the kinetic energy, right? They gains the kinetic energy, right? So and this electrons, they will be moving in a zigzag path, right? So all these, they will be colliding on another, they will get the kinetic energy, and they are set in a motion, and they will follow some zigzag path, right? So when this VBE, and yes, and this constitute, there is a motion, this constitute your emitter current. Okay, now when the VBE is applied, the voltage between base and emitter, right, it is applied because of your this battery, right? If this voltage is greater than 0.7 volts, if this voltage is greater than 0.7 volts, now what will happen? These electrons which are traveling in a zigzag path, they acquire more energy and crosses this first junction, right? So the energy is more than 0.7, and they will cross the first junction, that is emitter junction, right? So the electrons will be reaching into the p type of a base, right? The electrons will reach into the p type of a base. Now what happens when these electrons, they reach into the base? We know base is a region which is lightly doped. Let us consider it is 2% doping. Lightly means 2% doping. So that means the number of holes will be also, let us consider 2% only, right? And let us consider the emitter is 100% doped. That means 100% of electrons are there in emitter. So when the VBE is 0.7 volts, these electrons from the N-type emitter, they crosses the first junction and reach into the P-type of a base. Now these electrons and holes, they will recombine with each other, right? So only a very few, can I say, out of the total 100, out of the 100% of electrons coming from emitter, only 2% of electrons, they recombine with the holes. They recombine with the holes, right? So as soon as the electrons they reach into this P type of a base, they experiences a force of attraction. See, the positive terminal of VEE is connected to the, it is connected to the base, and which in turn connected with the P type of a base, P type semiconductor. So this 2% of electrons, yes, they will move away from the, they will move away from the base terminal and they will reach to the, right, they will come down and they will go into the positive terminal of VEE, right? Again there is a flow of electrons away from the base terminal. So this constitute the base current opposite to the flow of electrons. So I say this constitute the base current which is coming inside. Any doubts? The base current is coming inside, right? So as you know that the base terminal for CB configuration is connected to ground. So the voltage in base is 0. So the base current will also be 0. So we say in this circuit, from higher potential towards lower potential, only the emitter current is flowing, right? Only the emitter current will be flowing. The emitter current now it will be flowing from higher potential. It will go into the P type of a base, and in from the N type, see the emitter current is coming outside and it will be flowing in this circuit. Which current? IE. And this is why we say in CB configuration your IE is the input. IE is the input current, right? But if you remove this ground potential, your base current will start to flow, right? And that will be the base current will be coming inside, right? For the CB configuration, we don't want base current. Clear? Okay. Now let's see what happens here. So out of this 100% of electrons, when VBE is greater than 0.7, right? So only 2% electrons, 2% of electrons, they recombine with the holes and they will be coming away from this base terminal. And what about the remaining? This is only the 2% electrons we are talking about. And what about the 98%? This 98% electrons, they continue to flow in the forward direction. Why? Because we have made this emitter base junction to be more forward biased than 0.7, beyond 0.7. Let us make to be 2 volts, 5 volts, 20 volts, right? So this voltage gives you more and more force to these electrons. So they continue, the remaining 98% electrons, they continue to cross this reverse bias junction, right? So they have got enough force to cross this junction and they reach to the collector terminal, right? So now the terminal which collects the majority charge carriers is called as collector. So all the electrons will, 98% of electrons will gather at the collector. Now as soon as they gather at the collector terminal, so your connector terminal is connected with the positive of VCC. So these electrons, they continue to move away from this collector terminal, and they will reach into the positive terminal of VCC. And this constitute your Bay collector current opposite to the flow of electrons. So I say collector current is coming inside because electrons are moving outside. So the collector current is coming inside. Any doubts here? So can you see an amazing fact here is, if I do not connect base to the ground, what will happen? Let me change the color. Right? So my collector current will flow from higher potential towards, right, lower potential. So IC has started to flow from the collector terminal. It is coming inside, right? So this is the collector current is going to flow from the base. See, from the base what is happening? If I do not connect this to the ground, your base current will also get add into your collector current. So that means IC plus IB. And now this addition of both these currents, see, they will continue to flow in the forward direction, and it is coming out of this emitter. It is coming out of the emitter terminal. So this is nothing but emitter current is actually the addition of collector current plus base current, isn't it? And that is why we are getting the expression IE is equal to IC plus IB, right? So here in the CB configuration, we are applying the base terminal to the ground potential. So that means in this expression your base current is 0. Practically I will say negligible will be there. So what you are getting here is IE is equal to IC, and can I say output current is equal to input current? No change. So can I say output is very much constant on your input value? And this is the speciality of CB configuration in the circuits. When I want constant current source, we are going to use CB configuration in active region, isn't it? So see the current directions. Collector current is coming inside, base current is also coming inside, and the emitter current is leaving the transistor, coming outside. And that is why the symbol, you can see here, the symbol is showing emitter current is coming out from the emitter terminal, base current is coming inside, and collector current is also coming inside. So why this equality is there, why the current directions are like this, all we have got the answers. And why the CB configuration is used as a constant current source? Because in this your base terminal is connected to 0 volts. That means base current is also 0. So your IE is equal to IC, since output is equal to input. So this circuit, say it is a constant current source. Okay, you can see this animation. I have tried to put the animation, but it is not in a correct way. Please avoid that animation, right? So this diagram will show out of the 100% of electrons, 98 electrons are moving forward direction towards the collector, and only 2% are electrons are recombining into the base. They are coming inside of the base. right?